Renewable energy solar systems typically come in voltages of 12 volts, 24 volts, and 48 volt solar panels and can develop and store different amounts of power depending on the equipment. The charge controller limits the voltage and current being received by the batteries from the solar panels, usually with built-in fuses. The batteries then begin charging, and depending on the type of solar panel, you can get different voltage charges. An inverter rated to the voltage of the battery or batteries will then invert the incoming voltage into AC voltage, and depending on the inverter, you can run multiple wattage devices up to the inverter's rated wattage. Some of the main types of solar panels are monocrystalline, polycrystalline, and thin film. Monocrystalline panels are the most expensive and develop the most sunlight during peak sunlight hours with the highest efficiency and longest life. The disadvantages of monocrystalline is that the panel is in the shade or gets covered in dirt or snow, the entire circuit can break down. The first polycrystalline panels were introduced in 1981 and are more affordable yet still develop a high efficiency of sunlight during peak sunlight hours. Disadvantages of polycrystalline is they are bulkier, limiting space, and don't have as high efficiency as mono. The advantages of thin film are they are flexible, high temperature, and shading have less impact. The disadvantages are they are space limiting and have lower efficiency. Some of the main codes behind stationary fuel systems are Rule 64-700 marking, stating that a permanent marking shall be provided in accordance with Rule 2-100 at the disconnecting means, specifying the overcurrent protection, short circuit current interrupting capacity, and a brief system description. According to Rule 64-704, overcurrent protection, if the stationary fuel cell system is provided with overcurrent protection sufficient to protect the circuit conductors that supply the load, additional circuit overcurrent devices shall not be required. The disconnecting means installed in accordance with Rules 64-060 and 84-020 shall be labeled in a conspicuous, legible, and permanent manner, identifying it as the fuel cell system disconnecting means. Hydrogen and fuel containers, associated piping flanges, and hydrogen vent systems shall be bonded to ground by means of a copper bonding conductor not smaller than number 6 AWG, except as required for cathodic protection, according to Rule 64-708. Stationary fuel cell systems shall not be located in closed closets, bathrooms, stairways, high ambient rooms, hazardous locations, or any other similar undesirable location, according to Rule 64-710. Some of the main codes behind batteries are regarding the following rules. Rule 64-800, installation of storage batteries in renewable energy systems shall be installed except as otherwise required by the manufacturer. The interconnected battery cell shall be considered grounded where the renewable energy power source is installed in accordance with Rule 64-064. And Subrule 4 states that lead-acid storage battery banks for dwellings shall have no more than 24 2-volt cells connected in series, 48-volt nominal. Rule 64-810 for the battery and connections states that flexible cables as identified in Section 4 in sizes numbered 2-aught AWG and larger shall be permitted within the battery enclosure from battery terminals to a nearby junction box. Rule 62-812 charge control states that equipment shall be permitted to control the charging process of the battery.
So what actually is solar energy? Solar energy refers to light shining on an electrode submerged in a conductive solution, which creates an electric current. As we all know, or should know, solar has provided energy for life for billions of years. The greatest part about solar energy is that as long as the sun's still shining, we still have constant power, for at least half of the day. But if the sun isn't shining anymore, we obviously have some bigger problems to deal with. Solar panels are very interesting pieces of technology and have allowed the general public to generate their own power since the late 1830s, when the first solar panel was invented. Since then, we've made great strides to improving and optimizing these pieces of equipment by scaling them to massive sizes, attaching motors to the base so they can follow the sun throughout the day, and many more optimizing features. A very fascinating feature on solar panels is the solar inverter. The solar inverter is generally a large circuit that is attached in a junction box close to the panel. The inverter acts much like a rectifier, which transfers an AC source into a DC source, except the inverter takes the DC source and transfers it into AC. We need an inverter instead of a rectifier because the solar panel produces a DC power source. It is critical to have our generated power to be AC, as the applications that will require the solar's power will demand an AC source. The DC source comes from the battery that the solar panel is charging, and is then converted to AC when the inverter has something connected to it demanding its power. Rule 64-100, maximum circuit loading. This rule from the code states we cannot try to pump more power than the inverter is rated for, and that we are trying to keep the system running based on a continuous operation, meaning it will not turn off nightly or daily. Rule 64-104, utility interactive inverters mounted in locations that are not readily accessible. This rule refers to inverter's junction box being placed in an area that's not necessarily accessible. An area like this, for example, would be up high on a wall, located under the floor, or behind a shelf in your garage. All of these places are okay to mount your inverter, provided they meet the standards of Rule 64-104 and the subrules within them. Rule 64-106, connection to other sources. Only inverters and AC modules specifically approved for the purposes and identified as interactive shall be permitted in interactive systems. Rule 64-108, ampacity of a neutral conductor. This rule explains that the inverter output rating and maximum load cannot exceed the ampacity of the neutral conductor. According to Rule 64-110, single-phase inverters may not be connected to a three-phase system, and three-phase inverters shall have all phases automatically de-energized upon loss of or unbalanced voltage in more than one area. This can keep the system from running when it shouldn't and protect itself from damage. Rule 64-112 is the longest rule pertaining to inverters within power generation and refers to utility interactive point of connection. An interactive power production system operates in conjunction with and can deliver power to another power system, such as the utility.
These are some general rules for renewable energy power systems. All the conductors from different power or distribution transformers must be separated according to Rule 12-904, Sub-Rule 2, and 12-3030. For each individual electrical source, overload protection must be provided according to Rule 64-58, Sub-Rule 1. It is important to have a separate disconnecting means for a renewable energy power supply source from all conductors in a building, as stated in Rule 64-60, and it must be located within sight of and within 9 meters of equipment or integral to the equipment. Except provided for by Rule 64-210, conductors for DC renewable energy source or supply circuits installed inside a building, structure, or utility interactive inverter must be contained in metallic raceways, metal enclosures, or cables with a metal armor or metal sheath. Depending if it's AC or DC systems, there are different grounding methods stated in Rule 64-64. Most of the rules concerning DC systems. On top of grounding the system, a ground fault protection must be in place to prevent faults being undetected. The grounding connections must be connected to the grounding electrode and the connection location as close to the power supply as possible. If the renewable energy power system is located underground, it must follow the rules on 64-66. All the sources and power conductors must have overload protection. Conductors consist of metal sheath or installed in a metal raceway. Warning labels must be visible on each junction box. Disconnecting means and devices where the underground circuits can be exposed during service. A ground fault system must also be in place. Warning notice and diagrams for renewable energy power systems must be in place at each service equipment. Unless the renewable energy power supply is connected to a power service source, all systems need to be marked and labeled properly according to Rule 64-74.
When dealing with a solar panel installation, there are many rules that need to be taken into account. Many of these rules, such as conduit size and conduit fill, etc., we've dealt with previously in the course and are not exclusive to a solar panel install. I'm going to talk about code rules that relate solely to photovoltaic systems. These rules are found within Section 64 of the Code Book. One of the most important rules when dealing with a solar system is Rule 64-202. According to that rule, a device being supplied by a solar panel has to be rated for 125% of the panel's open circuit voltage. This means that a device being supplied by a solar panel with an open circuit voltage of 24 volts must be rated for 30 volts. This rule is extremely important because you want your load to be able to handle a slight increase in the output from the solar panel. Minimal voltage drop is also an important aspect of a solar system. According to Rule 62-204, the voltage drop of a photoelectric system shall not exceed 5% of the rated operating voltage. This means that almost all the power generated from the solar panel reaches the load. Rule 64-206 pertains to the rated current of the system and overcurrent protection. According to Rule 64-206, the current rating of a photovoltaic system shall be based upon the overcurrent protection of the circuit. The overcurrent protection shall not be less than 125% of the rated short circuit current of the photovoltaic circuit. When connecting panels together, the type of wire used must be in accordance to Rule 64-210. This rule states that flexible cords suitable for extra hard usage shall be permitted for the interconnection of photoelectric modules within an array. When doing a solar panel install, wires must be color-coded according to Rule 64-212. For a 2-wire circuit, red must be positive and black negative. For a 3-wire circuit, white, gray, or white with a colored stripe may be used as a neutral, while red is used as a positive and black is used as a negative. For higher voltage solar panels, DC arc fault protection is required. Rule 64-216 states photovoltaic systems operating at a maximum system voltage of 80 volts or greater shall be protected by a DC arc fault interrupter or other system equipment approved to provide equivalent protection. Rule 64-218 pertains to rapid shutdown. Rapid shutdown device such as an e-stop shall be provided for a photovoltaic system installed on a building or structure where the photovoltaic source or output circuit conductor is installed on or in the building more than 1.5 meters in length or 3 meters from the array. This rapid shutdown device shall limit the source or output circuit to not more than 30 volts and 8 amps within 10 seconds of rapid shutdown initiation.